Hello, good morning, Central. This is Mr. Werman coming at you. I hope you guys are having a good day. At least enjoying looking at the snow out there. Hopefully, it'll warm up for us here soon. So, there were some questions on finding the area of a circle. So, that's what I was going to go over here today briefly. So, if you want to stick with me for this, we'll go over it and hopefully this will answer any of your questions. Okay, so first thing we need to know for finding area of any object is kind of knowing the formula, right? So for circle, before I say that, maybe exactly. So area, of course, remember, area is going to be what's inside the circle, right? Perimeter is that line on the outside. When it comes to a circle, we actually call that the circumference. But if you were to have a rectangle, right, that perimeter is that fence that kind of goes around the rectangle. Area is that space inside that rectangle, right? So in this case, our area is all the space inside here, which we have illustrated here on this graph paper that I quickly drew. I used a little, I'm down my workbench, used a little jar here to draw a crude little circle, but there we have it. So area is space inside the circle. Okay, so we got the A, first part. Great. Not circumference. This one we're dealing with area. Okay, and then we have pi and we have radius squared. So pi, what is pi? Pi is this magical number. It's irrational. It goes on forever. I'm sure you're somewhat familiar with it. We just had Pi Day nary 9 days ago. So for pi, it's this number that goes on forever, and it starts out with being 3.14. It goes on to 3.1415926 something, something, something. Some of you maybe have memorized more digits than I have. That's as far as I have memorized. But for our purposes, and most of your purposes in the future, you're just going to use 3.14. Okay, it's going to give you close enough to where you need to be, unless the problem doesn't want you to just keep the number pi instead of actually turning it into a digit. Okay, so 3.14 for pi. Great. So it's just kind of a weird number, but that's what we use. And then we have r. So what does r stand for? R is the radius. So when they say r squared, that means the radius squared, or radius to the second power. Of course, second power just means radius times radius. All right, so that's going to be our formula. So what is radius? Well, let's look at our circle here. So as I said, I just drew the circle. We have what is in the center of the circle, which is the origin of the circle right here. Right? So if we look at this, we would see it is 6. There are 6 spaces between the outer edge and the center of the circle. Right? So it's also true if we go this way, 6 spaces. We go this way, 6 spaces. Okay? It's also true if we go across like this. Still 6 spaces. It's less obvious because it's not in the lines, but it's equal distant. This line is equal distant to the center. So it's 6 all around. So that's why we call it the radius. So if this here is the radius, and we said it's actually 6, this one's 6 here. Up here we have the diameter. So what is radius? How does it relate to diameter? Diameter is if you cut the circle in half, that's the line. So, of course, the diameter, if this is 6 for the radius, the diameter must be, yes, it must be 12, right? Because we have 6 and 6 being 12 altogether. Okay, so we have the diameter here. We will use that for circumference later, but we just need to know the difference between the two. So diameter, radius, this origin, this one in the center. Okay, we're all clear on the terms. So radius squared times pi is going to give us the area of the circle. So what is the radius? Well, since we said it's 6, let's square it. So what is 6 squared? Well, let's do this here. I'll write it out. We're getting area. We're just going to plug in that 3.14. We'll plug in that 6 for radius, and then we'll pull down that square. Okay, great. So what is 6 squared? Who knows it? You should all know that one. Memorize that one. It will come up again. It is 36. 6 times 6 is 36. And then we have 3.14 times 36. I should point out using order of operations. That's why we did this one first. We need to square that 6 because PEMDAS, please excuse my dear Aunt Sally. The exponent, there's nothing to do inside of parentheses here. So then we go to the E, please excuse. The exponent is next, so 6 squared, 36. And then we can do our multiplication left to right here. So we're up to multiplication left to right. So we have 3.14 times 36. So if you do a little bit of that, I think I've got enough space here for this maybe. Yeah. Let's get some paper for this one. If we have 3.14 times 36, right now in my head I'm doing, oh, I don't want to mess this up. Let me do a quick estimation. 36 times 3 should be about 36 times 2 is 72. 36 times 3 is about 108. So it should be close to 108, a little above because that 0.14. Let's see what it actually is. 6 times 4, 24, carry the 2. 6 times 1 is 6, plus 2 is the 8. 6 times 3 is 18. Ta-da. Add a 0. 3 times 4 is 2, carry the 1. Should say 12, carry that 1. 3 times 1 is 3, plus 1 is 4. 3 times 3 is 9. Ta-da. And we have 4. 0, carry the 1. 3, carry the 1. Okay, let's see if I did this right. I maybe made a mistake. Sorry, guys, I'm just doing this on the fly. You could always check me with the calculator and tell me if I did it wrong. But what I just calculated here is 113.04. So after I did that, of course, you all know that, 2 spaces, put that decimal point. Great. So in other words, we have calculated the area of the space, which is 113.04. Okay. Really quickly, if you feel like you totally got it, good. Let me just kind of give you one more quick thing with this. I think it's really interesting. The reason I did this on graph paper, we can show the radius very well. I like that. But also, really, each of these are 1 centimeter by 1 centimeter. Okay. So for one single square, this is 1, and this is 1. The area of one square is 1 centimeter squared, 1, right? So the area is really calculating how many squares are in here. So we could do a kind of a quick estimate of this. Let me do this. This might be best. I just do a little bit of this. Looks to be about there. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8 by, should be 8, 1, 2, 3, 4, 6, 8. So 8 times 8 is 64. So I just got 64 squares in there. Just do a straight in. Okay. And then what's left here on the outside? 1, 2, 3, 4, 5, 6. And then 64, I'll write it down. 6. And then this is about 7, about 8, about 9, about 10. So another 10 about there. Maybe 11. Okay. Round it up a little bit there. So if that's about 11 or 10, something like that, somewhere in between 10 and 11. So if it's 10 here, 10 here, 10 here, and 10 here, that is a total of about 10 times 4, 40. So if we had 64, is there 8 times 8, plus about 40 more, we said maybe 44 if it was 11 times 4, something like that. We'd end up with 8 and 1. So just by a rough calculation, yep, I got about 108 squares in there. Remember we said it was 113. So you can even see how the area works by this as well, by really just counting the squares to get a rough estimate. But hopefully that helps you guys understand this. Okay. If you have more questions, keep them coming. I like making videos and talking to you guys if I don't hear you back. All right. Hope you're all doing wonderful and taking care of each other. And I hope you have a great day. All right. Bye.